As an illustration, let's focus on a concrete example. Jane is considering investing in a plant to manufacture handsets. The project requires an investment of $100 million today. In year 1, that is 1 year from now, this project will pay $25 million. In year 2, it will pay $35 million, it will pay $45 million in year 3, and $55 million in year 4. Let's assume that the cost of capital for this project is 15%. We can compute the NPV of this project using Excel. We will use the NPV function that we learned in Module 1. First, enter the cash flows in order, starting with the cash flow today. Next, enter the discount rate. Recall that the NPV function in Excel treats the fair cash flow you give it as a cash flow in period 1. In this example, year 1. For this reason, the cash flow in year 0 is discounted separately. However, this is easy to do as there is no discounting in year 0. Using Excel, we obtain that the NPV of Jane's project is $9.24 million. The next question is whether Jane should take this project. To answer this question, we use the NPV rule. According to this rule, Jane should take this project because its NPV is positive. Let me explain why. It will be convenient to split the cash flows of the project in two: the investment today of $100 million and the future cash flows. What is the value today of the stream of future cash flows that start in year 1? The answer to this question, as we saw in Module 1, is the present value of those cash flows, which in this case is $109.24 million. That is, if she invests in the project, Jane incurs a cost of $100 million today, but in exchange gets a cash flow stream that she values today at $109.24. The NPV in this example is positive because the investment is lower than the present value of the future cash flows, a situation in which investing makes sense. Let me take this argument a bit further. Not only can we say that Jane should take the project, but we can also say that she is wealthier today by the amount of the NPV of the project, or $9.24 million. She is essentially buying something worth $109.24 million for only $100 million. You can think about the NPV as an increase in her wealth today. This reasoning leads to the second part of the NPV rule. If you are considering multiple projects but can only take a subset of them, maybe because you do not have time to invest in all of them or cannot raise the necessary funds to invest in all of them, you should take out of all possible combinations of projects the combination with the highest NPV. Recall that to compute the combined NPV of multiple projects, you just need to add the NPV of the individual projects. We will see an example of this rule later in this module.